Welcome to part 4 of my drone build project. In this project I'm building a hexacopter over many months where I am documenting video by video the different steps that I take to assemble this thing. My hope is that you can follow along and build something similar because I've had a tough time finding documentation that walked me through everything that I needed to know. In prior videos in this playlist you can see me assemble the frame. So this is a 1300 millimeter frame. Pretty big drone. And the prior video we set up the Herelink Air Unit, and today I am hoping to install the cube orange and remove it from this carrier board, hook it up to the core carrier board, which provides all the electrical signals to be able to connect speed controllers and the different power for other companion computers and devices, as well as for the UART and CAN interfaces into this. So today, follow along as we give this thing power. We're going to connect the cube orange, and I'm going to connect the S-Bus and telemetry connections to the Herelink Air Unit, so hopefully we will see data show up on the controller. So that'll be today's video. Follow along if you want to see how it all unfolds. Let's head on over to the bench. Okay, I want to show you what I've got put into place here so far. I saved you from filming and watching about 5 hours of soldering yesterday. But here's kind of the assembly that I've come up with for this core carrier board and all the electrical signals. So what I did was on each of the ESC pads, I soldered a 12 gauge wire and a 4mm bullet connector. This is going to hopefully make it easy to run the connections and the wires through the tubes from the arms all the way into the board. So I had 8 of these total, right? I'm building a hexacopter, so I'm only going to need 6. But the thought is, with the other 2, I did something like this where I'm coming out of it and I've made kind of these generic adapters where this one here, 4mm bullet connectors on each end to an XT30 connector, which will allow me to pull power into other devices. And so I'm going to be able to have 2 of these. And I just merge these together, so I have 2 XT30 connectors going to a single set of bullet connectors. So the way this works is you get this into some bullet connectors, plug it in, right? So that's going to get me some ancillary power to other devices. On this side here, this is 8 gauge wire and an AS150U connector. So inside of this, there's not only the power pins, but there's some data pins. And so I don't have a data wire connected yet to anything. I need to figure out what's that gonna connect to and how I'm gonna get the signal out of a smart battery. But that's essentially what that is for. So this will mount somewhere on the drone frame. It'll come out, and I attach these with bullet connectors as well. These are 6.5mm bullet connectors, so that it'll make it easy to mount the board and disconnect the wires and keep things very modular and run things through the drone as I assemble it. I still don't know how I'm going to mount all this in the drone yet, so I'm trying to keep things pretty flexible. Now the other thing I put together, I'll get to the air unit in a minute, is this Matex Sys. It's basically a BEC that gives 5 volt, 12 volt, and then there's a configurable one that I've got set up to output 5.25 volts. So on the input side, it takes 9 to 55 volts in. I put little labels on the wires. I attached an XT30 connector to this side with a large capacitor. And on the other side, I'm just using these kind of red battery connectors that I bought off of Amazon. And I've got 3 outputs then here. I got the 12 volt 4 amp signal that or power that I can use. I've got a 5 volt up to 4 amp power connection. And then I've got a 5.25 volt up to 15 amp connection that this is going to connect into the Raspberry Pi to power that. So I can make sure I have plenty of current to keep that from browning out and going into a low power mode. So what else do we have here? On the end of the air unit, I've attached the male end of these red connectors that will connect to my power sources. Okay, I labeled those with 12 volts so I know where they attach to. I've also made these little, I don't know, multiplexers or pigtails, whatever you call it. So what this will let me do is come out of one of these power connectors and basically split it into 4 different connections so I can attach multiple devices. So that's the way that works. And all I did was take you know, several of those connectors, twisted the wires together, and then put some heat shrink tubing over it. Soldered it, put some heat shrink tubing to keep it all together. And lastly over here, I just have an adapter right now. It's an AS150 to an XT90 connector, so I can use some of my existing 6-cell batteries to power this assembly up and test it out. So I'll show you how it goes together, and we'll power it up, and then we'll move on to installing the ArduPilot, the Cube Orange device in a little bit. So I'm gonna attach my adapter here, right? So I can attach my 6-cell battery. I've got my battery here, just for testing. I'm gonna leave that set aside. We'll plug that in last. Okay. So then on my core carrier board, I'm going to attach my BEC to one of these XT30 connectors. Okay, so now we have this kind of connected and powered up. Go ahead and turn on the Herelink controller as well. Okay, so then for my air unit, I want to feed it with 12 volts. So I'm going to grab the 12 volt signal over here, 12 volt 4 amps. I'm going to attach my little octopus cable here that I made, and I'm going to go ahead and attach the fan and then the actual power for the air unit itself. Okay, so that's how that all connects together. Go ahead and lay this out in a way where you can see it better. Okay, so it looks something like that. Okay, in a future video I'll show you, but I also made a USB cable. So I bought one of the USB-C up to 5 amp cables. You got to be careful. There's 3 amp and 5 amp versions, it looks like. So I had to hunt around a little bit for this type of a pigtail connector. So I got that, and I attached my other end of the connection that's going to go to my octopus cable. And that ultimately is going to end up going into this 5 1/4 15 amp connection, right? So that'll give me a good USB-C power source to go into my Raspberry Pi. In fact, I'm going to have to play with it at some point, figure out where I'm going to mount all this, but essentially, it's just going to power like that, okay? So we'll double check all these connections. 5 1/4 volt 15 amp. We got the 12 volt signal over here coming off the BEC going to the air unit, and we've got the input of the BEC connected to one of the ESC outputs from the core carrier board. All right, so we can go ahead and we'll look at our app over here to see if it's connected to anything. It's not, which is a good sign. So now I'm going to go ahead and plug in the battery here and power it all up. Okay. So you can see here, Raspberry Pi is lit. There's a little green LED you can see on it maybe. The BEC is showing power. You can see there's a couple of red LEDs in there. And the core carrier board has its green light going. It's a very bright light. And the air unit is booting up and the fan is spinning. So hopefully here in a second, yep, it's got an uplink to the air unit. It's showing that it's connected. So everything is good. Everything is looking powered and operational. So like I said, this took me, I don't know, about 5 hours yesterday. I spent soldering things together, cutting cables, trying to plan out how I wanted to run all this. And I spared you filming all of it and watching it through some fast forward motion because it was pretty boring. So we'll come back here in a few minutes and take a break, but what's going to happen next is this cube, orange plus, is going to get attached to the core carrier board down there. And then we should actually have signal. We're going to have to attach one more wire, I believe. But we should then actually start to get signal to our Herelink controller and start to see some of the telemetry coming out of this cube orange. So stay tuned. I'll be back in a few minutes and start to put together this next segment. Alright, so the next thing I want to do is remove the cube orange plus from the carrier board it came in. So on the bottom there's 4 screws. It's just a small Phillips screwdriver. I'm going to go ahead and loosen those up and take them out. They seem to not be releasing very well though. Actually, they're just really long. 1, 2, 3. Last one. And 4. Alright, so all 4 screws have been removed. The Cube Orange Plus can just pop out of the carrier board. And I believe this is an orientation to all this stuff. The Cube Orange Plus is going to be facing forward. And I believe we want it facing towards the front of the board here. I'm pretty sure it just slides on like that. Yep, just snaps on. And then the core carrier board came with 4 screws. Let's see if these are the same. If they are, I'm just going to use the ones that we just pulled out. Yeah, they're the same size. So we should be able to turn this over, and in the bottom there's 4 screw holes here that we're just going to screw this right back in. Okay. Alright, that's 2 screws in. Be careful about over tightening them. I don't want to tighten them too much and break any plastic inside the Cube Orange Plus. I'm not exactly sure what these are screwing to. Give them another half turn or so. And voila, that's done. Okay. So the Cube Orange Plus is now mounted to our carrier board. And it looks something like this. You come back in a few minutes and we are going to then connect the S-Bus and the telemetry port from the core to the air unit and hopefully see some readings from the Cube Orange Plus on our controller. Alright, be back in a minute. Okay, now to complete the wiring, you're going to need 2 wires that came with your Herelink Air Unit. One is a cable with 3 wires labeled UART. It's got a black, red, and yellow cable. And then there's another cable that has this white end that's going to connect to the air unit, and it's got 2 what look like servo connectors, and they're labeled S-Bus 1 and S-Bus 2. Okay, so we're going to plug each of these into the air unit. They're different size connectors, so they only plug into one spot. But they're going to connect on the side here, same spot where we got the power. So I'm going to plug the UART cable in first. Okay, and then I'm going to plug the S-Bus cable in. Now, from your UART cable, you want that to go to Telemetry 1 on the core carrier board, which is this top connector up here. And then the other connection is S-Bus 1, which must go to the RC in port per the Herelink docs, and on this core carrier board, it's the one labeled PPM, not the S-Bus port. The S-Bus port here is actually another S-Bus out port, I believe. So for this one, these ports look to be signal, closest to me here, signal, and then power, and then ground. And so for my signal wire, the yellow wire, I'm going to make sure that is the one on this last connector here, the PPM one, and plugged in like that. And those should be the connections to your air unit. I'm going to go ahead and put this other cable out of the way. And finally, we could power it up. You can see the Cube Orange Plus is lighting up orange now. The Air Unit's booting up. Core carrier board has green power LED, so that's all looking good. So then, hopefully, when this all comes online, we'll be able to turn on the Herelink controller and see telemetry data coming out of the Cube Orange Plus. I'm not sure if we actually have to load ArduPilot onto it yet, or if it comes with that firmware. So we'll check that out in a few minutes. So I'm going to take a break here. We'll come back in a few minutes and figure out how to view some data coming out of the flight controller. Okay, for this next step, I need to actually upload the firmware to the Cube Orange Plus. So I'm going to connect it with a USB cable. I don't have a battery connected, it's not powered. In the side of the Cube Orange Plus, there's a USB connection that I'm going to go ahead and just plug this in. The other end is already in my computer, so that should apply power and boot it up. So what we're going to do now is hop over to the computer and open up Mission Planner and start to upload the firmware. Okay, our next step is to install the firmware on our Cube Orange. So we just connected the USB connection on one side, and I'm going to go ahead and start up Mission Planner now, which is a software that you'll use to configure the Cube Orange, update firmwares, and you can view telemetry coming out of it. So this is the Mission Planner home screen, and what I'm going to do is go to the Setup tab in the top corner, and then I'm going to click on Install Firmware. I'm going to choose the Copter 452, the Hexacopter layout, and I need to plug in the other end of the USB connection into my computer. So I'm going to do that. Alright, so it just appeared here. It found the board. You can see the current firmware versions. I'm going to go ahead and hit yes. And I'm going to say this is a Cube Orange Plus. And I'm going to go ahead and upload that. Right, so our Cube Orange should now have the firmware installed on it. It's rebooting, and if I go to the Data tab, I should see it in my drop-down. I see it as COM6 Cube Orange Plus Mavlink. I'm going to select that and press Connect. Okay, and now you can see the telemetry is starting to show up here. You know, it's showing altitude, vehicle speed, and it's talking to it. So next step is I'm going to unplug this, and we will start the Herelink controller and verify that it's getting the same telemetry updates. Okay, now that the firmware is on the Cube, we should be able to unplug it from our computer, power it up through the battery, and see it connect to the Herelink controller unit. So I'm going to go ahead and unplug the USB cable, which will power off the Cube essentially. And then I'm going to go ahead and power it up from my battery that we've put together. So the Cube Orange, Herelink, and everything is booting up. I'm also going to go ahead and power on my controller. So that'll take a second. We'll come back and look at that. Just set it right there. And we'll make sure that the cube is talking to the controller and that we can see telemetry and data. Okay, this is now started up. So we do have the radio is connected. And if I go ahead here and start up Q ground control, we should see the same telemetry type of information that we saw on the computer.
Communication regained.
Okay, perfect.
Pre-arm, motors, check frame class and type.
Okay. It connected, and it's given some warnings here that there's no GPS lock, the pre-arm checks are failing, and this is because we haven't configured things in Mission Planner further. We haven't set the frame type, the batteries, or any of that. We'll come back and do that in a little bit here. But this is good so far in that we do have a connection, and we're...
Pre-arm, motors, check frame class and type.
And we are using, we're talking to the ArduPilot firmware on the cube. So what's cool that I noticed here is this little guy down here swaps between the map view and kind of telemetry view and the video feed that's coming into this. So what I want to do here is run a little experiment and see if I can get any data out of this Raspberry Pi. So I'm going to set that aside. I'm going to come over here.
Arm, motors, check frame class and type.
Take this USB to 5-volt cable that I made here, USB-C, so that I can plug it into our 5-volt connection that we wired up. And here I've got our Raspberry Pi. So I'm going to take that and I'm going to connect the micro HDMI to it first so that we can actually see it power up. So that micro HDMI...
Motors, check frame class and type.
I'm going to run into HDMI 1 port on my Herelink Air Unit. Okay, so I connected that in. Raspberry Pi is over here. Micro HDMI cable is feeding into it. And the last step, I'm going to go ahead and power up this Pi. And we haven't installed an operating system or formatted an SD card, anything like that.
Motors, check frame class and type.
But what I'm hoping to see is the bootloader menu start to show up, at least from that Pi. And it should show up down here. There it is. In this left hand, you know, if I swap between them, you can start to see the little Raspberry Pi symbol and what would normally be displayed on your computer monitor. So that's cool. That's all it takes to get a video feed back to your controller unit. You know, just it'll take a standard HDMI output.
Motors, check frame class and type.
So that's pretty cool. Now the next step that I want to do is this this controller unit actually will function as a Wi-Fi access point too. And so what we're going to do is enable the Wi-Fi access point so that I can connect to it from the computer over Wi-Fi. And what happens then, the flight controller will send its telemetry data through
motors, check frame class and type.
I need to kill this voice too. The flight controller will send its telemetry data through the air unit. HDMI signal also goes through the air unit. It will stream back wirelessly to this controller, and this thing has an access point then that will forward that information or allow you to connect to it over the Mavlink protocol from your computer. So what I want to do, I'm just going to go to the home screen here. So if you pull down your settings menu and you kind of expand the whole thing so you can read it all, there's an item here for hotspot. Okay, so you're going to just touch that and turn it on. What that will do is set up a wireless access point and give you an SSID that gets broadcast that you can connect to from another laptop or computer. Now you do have to configure what that is. So if you press the settings button up at the top, you can go into somewhere down here. Whoops. Under the wireless and networks, if I press this more button, you're going to get all the options, and what you want to do is connect or press tethering and hotspot there. And so in there, you can go to your portable Wi-Fi hotspot. It's either on or off, but then you have a setup Wi-Fi hotspot here where you can give it your network name. And in this case, I named mine Herelink, and you will type in the password that you want to use for your access point here. So we cancel that. So mine is on and broadcasting, and what we'll be able to do is go over to the computer here in a minute, connect to that remotely, and we should see the same information.
Arm, motors, check frame class and type.
In status in Mission Planner that we are seeing on this this controller unit. And we'll be able to start setting up the parameters in the cube, such as our frame type, prop size, battery information, and other parameters that we need to configure on this unit. So stay tuned. Let me hop over to the computer and we'll do the next steps. Actually, before we head over to the computer, I want to make one more change. I noticed that when I use the throttle and pitch controls, if I go up, it's actually moving the slider down. And if I go down on the pitch, it's moving the slider up. Right, and so you can see my fingers in the frame there. The other ones seem to work. So if I go right, I go left, I go right, I go left, the sliders match. So what I'm going to do is reverse the Y and R axes in this Herelink controller, which correspond to the throttle and pitch controls on the drone. So to do that, just to start from the beginning, when you're at your home screen, you're going to drag this down, and you're going to be on this radio status message where you can tap and it will open up this configuration screen. So I'm going to click on the joystick tab, and you can get to the spot where I was just looking at. And all I'm going to do is, next to the Y and R axes, there's a little reverse button that I'm going to tap. So I'm going to tap it for the Y, and I'm going to tap it for the R. And now that even though the input's going in the opposite direction, it will reverse the signal so that it'll get sent properly to Mission Planner. You'll see that when we go to calibrate the joystick inside of Mission Planner itself. So when I go down in Mission Planner, the throttle and the pitch will actually show that it's going down. Okay, heading over to the computer now. Okay, what I want to show now is my desktop computer. I'm going to connect to the Wi-Fi hotspot on the Herelink controller. So I'm going to go down here to the network settings, and I'm going to open up my Wi-Fi connections, show available networks, and the Herelink access point is set in here now. So I'm going to go ahead and connect. And once it finishes connecting, I'm going to open up Mission Planner. Now what's kind of cool about this is Mission Planner will actually automatically find the Herelink controller and ask you if you want to connect to it. So in my start menu, I'm going to start up Mission Planner. I'm going to go ahead and run that. And this box here, it's kind of cool. It says a Mavlink string has been detected. Would you like to connect to it? I'm going to say yes. And because the desktop computer or laptop is connected to the same Wi-Fi network as the access points broadcasting, it's able to automatically find that. So it's downloading all the parameters from the flight controller right now. And what we're going to do in these next few steps is just do some very basic configuration. I'm still learning a lot of the configuration of ArduPilot, but I've worked through a couple of the beginner manuals and or the beginning steps in their documentation and manuals, and we'll incorporate those into this video. So you can see here I've got mission planner up, and it's not reading the battery voltage, and it is getting altitude and speed set telemetry from the flight controller. So what we're going to do is start to configure this thing. And what I want to point you to is on the wiki that I published, I am maintaining from the main page, the drone wiki, I'm maintaining a page called ArduPilot Configuration, which is going to have every single thing that I change in ArduPilot to make this drone fly. This video, it's going to have just what's documented here. As I get into future videos and I set up the GPS and the speed controllers and so forth, I'll build this out with whatever settings I need to change. So at a high level, I got the initial setup that you do for a fresh firmware load, ArduPilot settings. And then I have some of the default parameters that I need to change to make some of the things work that I have so far. So I'm going to go ahead and stack these side by side, and we're going to start working through it. So in ArduPilot, I'm just going to follow these instructions here from the wiki that I wrote up. I'm going to go to the Setup tab. And on the Setup tab, there's this mandatory hardware section. I'm going to click it, and the first item that we got to go through is the frame type. So it's currently set as undefined. We're going to pick the Hexacopter pattern here. So I'm going to click that, and I want it to be the X pattern. So I'm going to click this second one on the X line here. So we got that. And then I want to jump to the initial tune parameter settings. And for this drone, it's going to use 24-inch props. So I want to change the 9 to a 24 on that. And right now I only have a 6S battery plugged into it. It will fly with a 12S when I figure out the smart battery I'm going to use. But for this video, I'm going to put a 6 in here. Battery cell when fully discharged, I want to leave that at 3.3. You might up it to 3.5 potentially to not drain your batteries so low. There's a lot of back and forth on the ArduPilot discussion forums and internet about that. But it comes with a default of 3.3, so I'm leaving it. I'm also going to do this add suggested settings for 4.0 and up, battery fail-safe and set and fence, and I'm going to say calculate initial parameters. So it's going to put these initial parameters in, and I'm going to say write to flight controller. So it'll give us some starting points for some of the different algorithms that it uses to fly the drone. Okay. Next up, we're going to go to the accelerometer calibration. I'm not going to be able to do all of this because this isn't mounted in a frame where I can move the drone around and put it in the different orientations. This first one here, I'm going to skip because it is going to ask me to place the autopilot on each edge, and I'm just not able to do that in this video yet. But I will be able to say calibrate level. It's sitting on a level bench behind me. So if I hit that, it's going to go off and do some calibration, and it comes back as completed. And I'll just click simple accelerometer calibration, and that is completed. So then the next step on the compass menu, we're going to come back here in the future. When you add the GPS unit on, it comes with its own compass, and it will show up in this list as well. And so that's where we're going to come back, and we're going to swap the compasses so that the primary compass it uses is on board the GPS rather than the one on the flight controller. So for now, I'm going to skip that, and we'll go to the radio calibration menu. So this is where I had to reverse those channels in the prior segment that I filmed to make it so that when I go up with the pitch, it will go up with the throttle, or go up with the pitch, it will go up in this display here. But what I need to do is press the calibrate radio button, And it's going to say ensure your transmitter is on, which it is because we're talking to it. I'm going to say OK. And then it's going to ask me click OK and move all RC sticks and switches to their extreme position so the red bars hit the limits. So you can see, note up here, there's no red bars showing in all these slider visuals. So when I say OK, I'm going to pick up my controller right now, and I'm moving the throttle and the yaw controls to their extreme edges, the maximum and minimums they can do. And then I'm going to do the same with the roll and the pitch. And I'm just moving it in a circle up and down just to calibrate the whole thing. And then the other channel that I have mapped is the slider wheel on top of the Herelink controller. So you can see that item that's mapped to channel 16 in the lower right down here. You can see that move when I move our slider wheel that we set up previously. Okay. And then I'm going to press click when done. And then we'll say OK. Okay. So now, if we go back to the data tab, you're going to see that the pre-arm checks are a little different. It's not complaining about the frame or anything. The battery voltage is still off and the current that it's drawing. So one thing I want to do is the next step on these parameter settings are some of the detail parameters that we have to change. So to do that, we're going to go into the config section here, and then we're going to go to full parameter list. And in this little search bar over here, I can type in the text, the prefix of what I'm looking for. So I want to change these battery settings, the battery monitor, amp offsets, current pin, and so forth. So I'm going to type bat underscore over here. And you can see I don't have all these parameters yet, the amp offset, amp per volt, and so forth, because the battery monitor is not yet set. So what I need to do is write a 4 into here. So I'm going to say that we're going to be detecting analog voltage and current on this battery. And I'm going to press write parameters. What I'm going to have to do is reboot the flight controller now for it to reset and kind of redetect the extra parameters that I need. So to do that in ArduPilot, you can hit Control F, and it will bring up a menu of actions. And down in here, there's one called Reboot Pixhawk, which I'm going to press. Are you sure? Yes. Hopefully the microphone picked up the chime behind me of it rebooting. And what we should end up with is you can start to see the battery is getting detected. I got a 6S battery though, so the rest of these parameters aren't set, so it's not quite accurately detecting the voltage. So we're going to go back to the config tab. Whoops, it must be loading the parameters. It's connecting. Okay, and if we go to the full parameter list again, and now I type in bat underscore, you're going to see a lot more parameters show up for this first battery. So the first one I'm going to set is this bat amp offset to 0.37. Now the core carrier board recommends setting that to a 0.45, but that was causing negative current readings to show up on my heads-up display. Looking through the ArduPilot forums, a gentleman suggested to use it as 0.37, and that seemed to work for me. There's also some guides out there about how to accurately tune the thing if you have a benchtop power supply and so forth, and you can get it more accurate than what I have here by doing some of those steps. Next one is bat amp per volt. So we're going to come in here, and I'm going to set that to 50. And then bat current pin is going to be a 15. And bat voltage multiplier will be a 15.3. And the bat volt pin will be at 14. So we have 0.37, 50, 15, 15.3, and 14. And when I write that, now if we go back to the data tab, My battery voltage is 23.22, which is accurate with its current voltage level. And the entire system is drawing 0.7 amps at this point. I've got the Raspberry Pi plugged in, the Herelink Air Unit, and the flight controller itself. So it's fairly accurate in what it's drawing there. The other item that we can set here right now, if you start to use your controller, Q ground control, and the pre-arm checks, it's going to check that the safety switch has been flipped. Because on the Here 4 we don't have a safety switch, that'll be for a future video, but I'm just going to go ahead and set that now. The Here 4 docs actually say to set this parameter called BRD Safety Enable, but it appears in the later versions of ArduPilot that I'm using, it's actually called BRD Safety Default. So if I come over here and search for that, I want to set that to a value of 0 to disable it. And I'm going to go ahead and write that parameter as well. So that's kind of the starting point of this controller. We need to, in future video, set up the GPS. I'm going to try and walk through setting up the Here 4 GPS and the RTK ground station unit. And then hopefully from there we can start to dive into a little bit more with the Raspberry Pi connection and the video feed from it. I also got to figure out the camera that I'm going to buy and mount on this drone and how we're going to control and manipulate the gimbal. And then once we get that figured out, I should be able to mount all this hardware in the drone and take it for a flight. And of course, I got to get the motors working too. That'll be a future video where I got to figure out how to take these Hobbywing X6 motors that Speak Drone can and get them connected to the flight controller. Advantage there is you're supposed to be able to actually see motor RPMs and telemetry and so forth in these various kind of status areas. So speed controller 1, current, RPM, temperature, voltage. I should be able to see for all 6 of my motors and speed controllers what specific values they're operating at. So we'll figure that out. So that's all I got for today in this video. It's a pretty straightforward setup. The Herelink unit makes things super easy. I'm really impressed with how well this works, and just start streaming data from the flight controller back to the the hand controller that I use, and from there can set up an access point and go right into a computer or a laptop and connect all those together. So very cool set of hardware that this is using. All right, I'm going to close this video out. That's all I got for now. We should have the next video up in a couple weeks when I start to work on the GPS components. Take care.